Howdy, it's tubalcain again, your YouTube shop teacher, and this is Machine Shop Tips number 490, converting a Delta bandsaw into a metal cutting bandsaw by the DC motor method, variable speed. Now be sure and watch the two videos before this, because this is a three-part series. Let me just show you real quickly on the screen here what the video tips numbers are. As you can see here, there are three videos in this three-part series. The top one there is converting the saw into a metal saw by the pull gear method, and the second one, which I just showed you here in the opening screen, is with the gear motor, and then today I'm going to do the DC motor. Possibly you can't see real well, but behind the large pulley here is the right angle drive motorized gearbox, and that has reduced the speed, as you can see here, so it's suitable for metal cutting. I spent a lot of time in the previous video talking about the different ratios and experimenting, and this is all an experiment, including this video. You see, I already have a metal cutting bandsaw. You've seen in many videos. This is the 14-inch Boyce crane that I use all the time. So I don't really need one. What I'm doing here is suggesting different ways of converting your Delta bandsaw, a very popular bandsaw, into a metal cutting saw. So what I'll do first here is to strip off this motor. I'm no longer going to need that. And the pulleys, because I'm not sure what pulleys I need yet. And then, off camera, I will mount the direct current motor and controller. I have made several videos using this DC motor and controller. Now I have two of those, so there's one already on my drill press. You probably watched that video. So this is the one that I'm going to mount on the Delta saw and see how it works. Now I have been troubled with these by low torque at low speed. And in the previous video I was greatly troubled by belt slipping on the pulley. So these are two problems that I have had, and continue to have probably. I expect to have them on this one, as a matter of fact, now from what I learned on the last few. And as I said in the other video, I think I learned more from doing these videos than what you will learn by watching them. But what I'm going to do is mount this on the saw, and I'm not going to show that all because that's what took so long in the other videos. Also, I'll do the experimenting to determine what pulleys and ratios and all of that good stuff that I need to do off camera to shorten her up here. So I'll see you in a little bit. Here's the setup so far. I wasn't going to show all this, but at the present time the motor is at a 450 RPM, which gives me a shaft speed here of 300, which is way too fast. But I took a sample cut, sawing steel, and it instantly stalled. That is, the motor stalled, not belt slipping. So that was an abject failure. Now I was warned about this. See, the beauty here is if I had torque, I could slow it way down or speed it way up. But that's not working out. Furthermore, that pulley there is so wallowed out. These are all used pulleys, but that's what you hear knocking there. It's just so oversized. So I really need to get other pulleys. So, and I don't want to spend money because I would need dozens of combinations of pulleys here to try to get where I want to be. But let me work on this a little bit more and change pulleys if I have them. I don't have a whole lot, but remember what I had from the last video. I got a pile of pulleys there and belts, and this just is very time consuming to do this and try it. And this may just be a total failure. I don't know, but I just thought originally when I came across this multi-drive here that this would be amazing. I was told that DC motors did not have a lot of torque at slow speed. Okay, now there are little pots in here, little adjustments for speed. And I'm wondering if there are some of those that are also for torque, and if anybody knows anything about that, let me know. Although this is, you may be watching this 5 years from the time that I made it. All right, I'll see you in a little while. Now look what I've done. I got the 12-inch pulley on the bandsaw, a 4-incher on the motor, and that's about only 350 RPM on that DC motor. There's absolutely no torque at all. And I'm at the blade approximately 400 feet per minute, which is more than I want. Now watch the pulleys as I saw 1/8 inch steel and stall it out. Can you see that with just 1/8 inch steel that I'm actually stalling the motor, so there's just no torque at that speed. And I would like to run it at a higher motor speed, but yet retain a relatively low speed on the main shaft. Okay, here's my final hurrah. That's a 2-inch pulley there. That's a 12-inch pulley, which is a 1:6 ratio, so it should come to no surprise to you that at 600 RPM here, which I have adjusted it to, I'm getting 100 RPM on the shaft, and that nets me a blade speed of 350 feet per minute. So I believe what's going to happen here, if I really load it down, obviously, is that the belt's going to slip on the small pulley because there just isn't a whole lot of wrap on that. So I would say this is probably the slowest speed that I can run it and still have some torque. But I would have the ability to very quickly speed it up and cut wood, although really it would require a blade change to do it properly, because that's a pretty fine blade that I have on there. And one thing that I haven't mentioned, and I know people are going to bring this up, is why don't I use a variable frequency drive? And that probably would be a better, far better solution than this. But of course I need 3-phase motors, which I don't have for this demonstration, but that would probably be a good solution. Also, many men have set these up using transmissions, typically like you might find on a small garden tractor or riding mower, or something along that line, and that would be quite functional too. Again, this is a little bit hard to guard because that pulley and everything is so large. It would be quite a large belt guard. Let me turn the machine around and very quickly demonstrate. Alright, it's turned around, and originally I had plans on mounting the control box up on the overarm here about where you see that light, but I'm not going to do that because this is just a short demonstration, and I do not intend to keep this set up because it's just not all that good. So let's saw some 1/8 inch stock here to start with. 1/8 inch steel. Actually, that cut quite nicely. Alright, I'm going to try some different thicknesses. I've already cut 1/8, and that's about 3/16. I'm going to use just a little bit of this bowl lube, kind of a dry, waxy lubricant on the blade, and see if that helps any. And I'll even rub a little bit on here. I don't know if that's going to work or help any, but what the heck. Alright, that's not bad, but it isn't cutting all that fast. And I'm making straight cuts. I'm making no attempt to make curves or arcs or anything like that. Now for some 3/4 inch thick steel. I'm going to put just a little bit of cutting oil on there. This probably isn't really a good idea because it just messes up the whole saw. that's cutting nicely. And I'm pushing very hard, and there doesn't seem to be any tendency for it to be stalling or slipping. So at that speed, I have sufficient torque with that DC motor. In fact, I'm pleasantly surprised. I'm trying to preserve the blade here with a little bit of lubrication. And then, I'm going to move some things out of the way here. That's the same speed, but let me crank it up a notch. Again, that's the same speed. I'm speeding it up. So that quickly, without a blade change, of course, I can go between wood and metal. Well, you know what? I'm pleasantly surprised at that, because that's 3/4 thick metal. The 1/8 inches is no big test, and it didn't stall. So I think I've found the sweet spot for this system. So I'm a little bit more enthused here and satisfied than what I know I sounded discouraged there possibly in one of the video clips here. Now this is 1/2 inch aluminum, so I'm going to saw in just a little ways with the speed that it's already set at. Then I'm going to crank it up a notch here, but of course this isn't a skip tooth blade, that's just that 14 tooth, so it's not going to cut real fast. But let's check out the difference between a relatively slow speed and a faster speed. Wow, that really cut through. That was the same speed as I was using before. So let me crank it up. And I do not know what speed it is. I'm not going to measure it. I'm just going to... That really cuts. And will it cut wood? This is maple. Oh. I do like that feature that I'm able to change the speed real quickly without any belt changes or any other nonsense like that. So I achieved just a little success there. I'm a little bit excited compared to the way I started out here a few minutes ago. This aluminum is 1 1/8 thick. This is 1/2 inch thick steel, and I've slowed the speed down again. Oh, that cut right through real nicely. And that's a lot louder than my other saw. It seems to be a little bit of chattering or something, but I almost needed ear protection for that. Now I'm going to take some readings here in feet per minute. Remember that the red dial there is the feet per minute. And I'm going to put, so right now I'm at 600 feet per minute. I have to add a 0 because I'm on the second scale right here. But with my left hand I'm going to rotate the variable speed knob on that controller to show you what I can do here. So now I'm slowing it down. That is 300 feet per minute approximately, but I just know there'd be no torque there at all. And I can very quickly change it. Alright, that concludes this video. That's as far as I'm going to take it, and I have mixed feelings about this. One, it seemed to work pretty good at the higher speeds, but there's just no oomph there at the real low speeds, which is what you need for cutting steel. So that's a disappointment to me. And you know what? I'm going to give you the director's choice here of the 3 different systems, if I dare say so, and that will be the pull gear. To me, this was the easiest to use and the most successful, and could be easily converted from slow speed to high speed back into the woodworking direct drive. So, but there just really aren't any of these available on the market, so unless you make your own, like our good friend from Australia. Watch his videos. So, all right, this is the director's choice. At the high school, I had a dual like this, only I think mine was smaller. It was a 16-inch wheel. I'm not sure what size this is, but it had variable speed, and there is the crank there. And a blade selector guide up here, as well as a speed guide. And right here, a little tachometer. And of course there is, let me zoom in just a little bit here. Remember, this book is 70 years old. The blade welder, and there was a power feed on here, although mine had long been disabled, and mine had the filing attachment as well. But there's the pedal for the blade speed, and there was a little receptacle here to catch the chips. So these are, and as far as I know, that bandsaw is still at the high school in the old shop, which is now used as storage. I would like to buy it, but I never could get it in the basement. It was a very, very heavy saw. But the duals were wonderful saws and fully adjustable. And that's kind of what this video is about, adjusting the speed with a variable speed DC motor. I'm constantly thinking about whether or not these methods would be usable in the other types of bases on the Delta saws. Now this DC motor is a full 12 inches long. DC motors are always extra long because of the armatures and the brushes and all of that. So with the 12 inches being measured and then going into this saw, measuring from the pulley back, I do not have enough room, so it would not fit in there unless I took the front cover off. You know, there's 2 covers. There's one on the front and one on the back. With the front one off, it would fit, and the rear one here could be put on. So that would be a possibility to fit into this closed cabinet. I don't know about the other open ones, but this is a relatively bulky motor. However, I know there's really not anybody out in YouTube land that's going to have one of these controllers and a DC motor. By the way, that's a 3/4 horse motor. That's not just some little Mickey Mouse toy. So I'm surprised that it doesn't have more torque, but I guess I proved that in my drill press videos a while back. But that concludes this video series with 3 different methods of slowing down a Delta bandsaw, and then I mentioned other options now. The jack shaft, I showed pictures of that in the last one. I talked about variable frequency drive just a few minutes ago, and transmission. So there's all kinds of ways to do it if you have a desire to convert one of your bandsaws into metal cutting. So I hope you like this series. This is tubalcain saying so long for now, and I'll see you in the next video.